What do you notice about this pattern? What are you adding every time to get to the next number?
5, 5, 5, 5, 5.
Okay, so 5 is the constant difference between the terms. This is your first term. So you call it T1, right? So you can say T1 equals to 7. So then what is T2?
12.
And T what is equal to 17?
T2.
And T4 equals?
22.
And T5 equals?
57.
Okay, so I'm going to let the letter A be the first term. So what is the first number in that pattern?
7.
So then A equals to 7. So I'm going to write A equals to 7, but not capital A, little a. A equals to 7.
Is this algebra?
It's kind of like algebra. Yeah, so this formula over here, this is called the general term. Okay, Tn is, this over here is basically a value. So like the 7, that's T1, right? So T1 or the 12 or the 17, those numbers can be, they can go here. And then the A is your first number, that's 7, and then the D is your difference. So the constant difference, we're going to call that D. Okay, so in this example, what is D? We say D equals 5, but oh, not capital D, little d. You see, no, but then you substitute. You put the 7 where the A is, and then you put the 5 where the D is, like that, right? But then the 5, normally you would put the 5 in brackets, and then you have to use the distributive property here. Because remember, you must, if you got plus and you got times, so what do you do first? You've got to times first. So then you have to times the 5 by the bracket, and then you add on 7 to the answer.
But then what is n?
Oh, what is n? N is the position. So if you want to go first, what is the first number, the second number, the third number, 1, 2, 3, 4, 5, the fifth number, the sixth number. N is your position. And then Tn is your value. The value is the number that's like 7, 12, 17, 22. Those are values. They go where Tn is. So I could substitute, I can times the bracket like that, distributive property, then you add on 7. And so if you simplify, you're going to get Tn equals 5n plus 2. Because you can't add n's and constants, remember. So you just got to add these two constants, you only get plus 2. This is called the general term. Okay, so with the general term, like let's say n equals to 1. If you let n equal to 1, then, okay, obviously you can't use capital N. So you're going to have to say, like, if n is equals to 1, then you can say, in the place of n, you're going to put 1, like there's a n and there's a n, so then you're going to replace those with 1s, like that. Okay, but you don't do it like that. 5n plus 2, and then you work it out. So then you're going to get here T1 equals, it's going to be 5 plus 2, which is 7. So that's telling you the first term is 7. You see, like there's the 7. Okay, and then let's say n was 5, then this is going to be a 5. That number there is going to be a 5. That's going to be 25. So that's going to be 25 plus 2. That's going to be 27. So the fifth number will be 27. So if you look here, 1, 2, 3, 4, 5, you can see the fifth number is
7.
wow. Okay, but you can also do things like which term is equal to 32. Okay, so in a case like that, you have to let the formula equal 32, like this. That's a linear equation. You solve it, so you're going to get 32 minus 2 equals to 5n, and then you get 30 equals to 5n, and then divide by 5, and so you're going to get 6 equals to n. So that is telling you the sixth term is equal to 32. Remember, the question was which term is equal to 32. So that's your answer. But if the question said which term is equal to 33, then this of course would be like that, 33. That's going to be 31, and then this is going to be 31 divided by 5. but that's not a natural number. Okay, so then you're going to say this is not a natural number because n has to be a natural number. Okay, so that means there is no term equal to 33. That's what happens if you get an answer which is not a natural number. Okay guys, so I hope that you found this video useful, and I hope that you're going to like and subscribe it so that you can stay tuned with all of the next developments. Until next time, hope that you enjoy math.